Hello friends, today we are going to learn step 7 Microwin smart software which is used for S7200 series of Siemens, in which we are see the different kinds of instructions, hardware configuration, symbol table, cross reference, system block and communication. So these are the points we have to cover in particular subject. So first of all, we open the software and first we are configuring the hardware. Here if you double click on CPU, then system block is open. First of all, I wanted to use the SC30 hardware, so here inputs and outputs showing how much inputs are available in this CPU and how much outputs are available in this CPU. And first of all, how to do the communication of PC and PLC. So you have to click on IP address. So this is our CPU IP address. It is a by default, you can change, but we are not changing in CPU, we are changed the PC IP. So according to this IP address we are changed the PC IP. Here I would like to change Ethernet, change adapter options, click on Ethernet, click on Internet Protocol version 4. So already I have configured the IP address in this series. Here 192.168.2.1, and here I am configuring in same series 192.168.2.20. So this is PC, so we can easily communicate the PLC. Another one setting is also you can do set PGPC interface. Set PGPC interface, you have to select the Realtek PCI GB family controller TCP IP auto 1. So in your PC you have to select the Ethernet card. So okay, so this is our main selection. So you can easily communicate with the help of this software setting, communication with the PLC. Now ST30 means 18 digital inputs and 12 digital outputs. Here CPU have a total 18 digital inputs and 12 digital output. Another option is retentive ranges. Retentive ranges, if you would like to some of the ranges in PLC which are using in the program, and you wanted to save the data in particular address under the power of condition, so you can select the ranges of the addresses here. Then security means different kinds of security. If you disallow upload the program, you can select this option. Minimum privilege, already you can read here instructions what kinds of password protection privileges here, so you can select anyone according to your requirement. Startup, if when PLC is on under that condition, natural means select the CPU mode after startup, means whenever CPU is in startup, what mode out of the CPU you can select here. Run, stop, generally we are using the run. Okay, so this is the system block, and you can first of all configure the system block. One more thing is, if you are using the another digital input output extra, so you can select here. If I wanted to add digital input according to my project requirement, 8 digital input and 8 digital output, so you can select here, and this is the address. Another one is if I wanted to means if I have required analog input and output, so according to project requirement, number of input output calculated, and you can select here 4 AI 2 analog output. So this is the address range. Signal board, if in your project there is one input or one output or one analog input or one analog output is required, then you can select the signal board, cost effective product. So you does not wanted to select the expansion module. These are the expansion modules, total 5 expansion module you can put it here. Now this is our configuration of hardware. Okay, now here how to write the program and how to structure program, just we are look at here. Now main OB1 means continuous scan in the PLC. This is main organization block. Generally we are not writing the logic in OB1. You can write, but it is continuously executed. So we are using the subroutines, means different kinds of functions, and these functions we are calling from the OB1. So we are using subroutine as functions. First we write the first function as a manual mode, another function we write as a auto mode. Now the OB1 is called the different functions like manual and auto. So we can open the OB1 and call the manual function and call the auto function. This is our always on bit. You can write here auto manual mode as in the form of the bit, but temporarily I am writing here always on bit. It is necessary. Before the block you have to put. Now we can compile. Total arrow is 0. Now one logic we have to write in the manual mode. Manual mode we are writing the start stop condition, but before that we have to symbolize inputs and output in table 1. First input, IO symbols. In IO symbols, first input name is start input. Another input we can write as a stop input, and one output we have to configure, enable. Okay, so after configuration of addressing we have to write in a manual mode start command, start input, stop input. But here we have to see that in start push button is generally or normally open condition. When we press the push button, input is coming into the PLC, which is momentary. As soon as we press button, input is coming, and if release, the input is going to 0. So here we using the NO contact. Another input we are using as a stop condition, stop push button. So it has an address 0.1. This is stop. Now physically normal condition, in the normal condition stop push button is NC condition and it is continuously on. So in program it is normally open and in program it is normally NC, because physically stop push button is continuously NC and continuous input is coming into the PLC. So this condition is arise if we look at the condition, enable. This is our Q 0.0, one of the output enable. Now when start push button is pressed, output will be on, but as soon as we release push button, start push button, output will be off. And this stop push button is continuously on because of physical it is in nature NC, and so we have to one latch right here, latching here. It is I think Q 0.0 is the latching bit, so we have to connect here. So now start stop condition has completed. When start push button is on, stop push button is already on because of the NC in the physically, and start push button, when start push button is on, enable command or output will be on, and when enable output on, latch has been completed and output is continuous on. Whether start push button is on or off, the output will be continuously on. Now to close the output, to off the output, we have to press stop push button because it is physically NC. So when we press the stop push button, the NC become NO. That's why this part is break and output will be continuously off. So this condition is start stop condition our. Similarly logics, we can write the logic here, and now status chart. Before that we are one of the value we can write here, symbol table. First of all word in different kinds of forms, VW0, VW2, VD4 and VD8. VW0 means it is a one word value, becomes it becomes by 2 byte. This is data 1 and this is data 2, value 1 and value 2. So we can write the address such like that. Now we are using different instructions like move data. So first of all we move the word, so you can transfer any constant value or any address value to another address value, or so you can. Now I think I want to like 5 value transfer to VW0, so you can transfer. Always on, always should be there. Similarly, if you want value double word, then you can transfer the 5.0, no sorry, VD4 value integer value VD8. So here you can transfer any value to any address, or any address value to the any address values. Similarly, you can use this kind of instruction. This is bit logic, positive H. If you would like to input on positive edge of any input, so these are the instructions you can use as per the requirements. Similarly, if you would like to clock, means if you would like to set the RTC and as set RTC and read RTC, I will give the sample program in description. Here you can set the RTC and read the RTC, means you can set the clock of the CPU and according to that read the RTC. Communication, different communication are available. Compare, if you would like to compare both value, means suppose if you compare integer, means here VW0 is our integer value. If data 1 value equal to 5, then output will be on. So maybe Q 0.1 or 0. So yeah, you can write in this way. Similarly, if you are using the byte, you are using the integer value. If double word, then anyone can use as per the requirement. Convert, if you want to convert the value integer to byte, integer to double integer. Suppose my value is integer VW0 and this is my VW4. So here integer to double integer value you can convert, and also convert double integer to real, means copy and paste. Here VD we can write VD8. So this can be converted. Counters, up counter, down counter, generally we are using up counter C0. This is our counter and it is a preset value. Preset value may be in terms of data 2, maybe VW2. We can here write value, we can also write the constant value here, and it is a reset. If you like to reset, then you can put here any value, maybe I0.0. During the start input, the counter will be reset, and up counter during the here we can write as a stop input, and here so how much time start input is coming, it will be calculated by the C0, and stop, during the stop time counter will be reset. So floating point and floating point math, add subtraction, you can add any two values here. If you would like to VW4 and VW8 sorry, VD4 and VD8. You can here another value you can write here. So these are the values. Similarly, integer value addition, subtraction here. Okay, and move already we are seeing. Program control. So these are the basic instruction. You should use that side. That's how you can use basic variables. Okay, now in another chapter we are making the recipe, how make the recipe of the system. So we can use, means we can learn the recipe, how can make the recipe, how can make the data log. So another chapter we will see. Thank you very much.